A mature Salesforce organization is a massive repository of information. It is common to find hundreds of interconnected data objects storing everything from basic customer accounts to highly complex financial transactions. To manage this vast ecosystem, administrators typically rely on the standard Object Manager, a traditional text-based tabular menu system. But a linear list of names offers no structural context. Scrolling through alphabetical rows of objects tells you nothing about how they relate to one another, or which specific objects depend on others to function. This creates a significant operational risk. Modifying a single data field on one object without understanding its macro-level dependencies can inadvertently break active workflows or disrupt reporting downstream. This lack of context introduces friction during the design phase. It becomes highly difficult for technical developers to clearly communicate proposed structural changes to business stakeholders using only spreadsheets and configuration menus. Attempting to scale an enterprise data architecture without a clear, spatial understanding of the system is a severe structural liability. Salesforce addresses this natively with Schema Builder. This tool takes hundreds of isolated rows of data and instantly expands them into an interconnected geometric web. Its primary function is translation. It converts complex relational databases into a unified, node-based graphical interface, where every object, field, and relationship is visible on a single canvas. Architects rely on this visual environment for three distinct operations: designing new solutions, analyzing the impact of proposed changes, and maintaining accurate system documentation. By mapping relationships graphically, the abstract logic of a relational database becomes immediately comprehensible. A project manager or a sales director can look at the canvas and grasp how their data flows without needing to write a query. Because this map updates in real time as the system evolves, it provides dynamic, accurate documentation that rapidly outpaces static spreadsheets, documents that fall out of date the moment they are saved. A live visual representation creates a shared technical baseline, reducing the communication gaps that often lead to architectural errors. On a clean Schema Builder canvas, architects drag and drop an isolated node representing a new custom object directly onto the grid. Next, they populate it by stacking data fields inside, immediately defining data types like text or numbers, bypassing rigid multi-screen wizards. If an architect needs to pivot, renaming a field or deleting an unnecessary column entirely happens instantly with a quick menu selection. This visual instantiation accelerates development, allowing a designer to move from a concept to a tangible working prototype in minutes. Moving beyond isolated creation, a second custom object appears. To link them, we establish a loosely coupled lookup relationship, visualized by a thin dotted line. The independent objects reference each other without strict dependencies. But sometimes business logic requires strict rules, a master detail relationship. A master detail configuration represents tight coupling. In this structure, a child object's existence, security settings, and ownership are entirely controlled by its parent object. If the parent record is deleted, all detail records are destroyed with it. Schema Builder relies on visual syntax to identify critical differences instantly. Notice the thin dotted line become a thick, solid directional line, clearly defining a strict parent-to-child hierarchy. Dragging this connection actively configures the underlying relational database schema in real time. Architecting these relational frameworks visually ensures structural integrity. It prevents developers from making blind connections and accidentally generating orphaned, disconnected data records down the line. Scaling into a mature legacy org reveals a dense web of intersecting nodes. To expose hidden dependencies, architects perform impact analysis, tracing how a modification to a central object cascades downward to child nodes allows them to instantly identify automated processes that would fail. This proactive step locks down system safety. It ensures a minor adjustment doesn't result in the accidental corruption or mass deletion of critical downstream data. In large-scale environments, tracing these relationships is a necessary check to identify relational conflicts before they reach the production environment. While mapping these macro-level dependencies is crucial, configuring a Salesforce environment eventually requires drilling down into precise micro-level field properties. The visual data model excels at rapidly assembling the overarching structural framework of the database. However, Schema Builder has a strict operational boundary. It is an engine built specifically for design, visualization, and rapid structural modification. This split-screen comparison highlights the division. On the left is our structural map. On the right is advanced configuration. Schema Builder is not designed to replace traditional menus when applying these deep back-end settings. You cannot use the visual canvas to configure complex logic, design page layouts, or apply granular field-level security toggles based on user profiles. Those mechanics require the depth of the tabular interface. The definitive workflow utilizes both toolsets. Architects rely on the visual canvas to map dependencies and establish the framework, and then migrate to the tabular setup menus to dial in the granular mechanical logic. Schema Builder serves as the architect's essential blueprint. It maps the dependencies and aligns the development teams, standing distinct from the system's final, deep configuration.